This is section 5.7 and 5.8. And in order to do this section, which is financial models and unrestricted growth or decay models, basically applications of logarithms and exponents, you're going to need to use this formula sheet. Now you will be given this formula sheet in On Level. You will be given a version of it in Pre-AP as well. When you look at this particular sheet, notice there are 1, 2, 3, 4, 5 formulas. The first formula is simple interest. We learned that when we were in junior high. You will not be using that necessarily on this particular section. But what you do have to understand is what it stands for. It says interest, the interest you earn, is equal to the principal, meaning the amount that you put in, times the rate, which is the interest rate that they're going to give you, times the time. So we've got interest equals principal times rate times time. And I'm going to show you an example of a problem that would be a simple interest problem. If we were to take this particular word problem right here, and it says a credit union pays interest of 4% per annum, that's another word for per year, and we take out the compounded quarterly. We just say it pays 4% per annum. You put in $2,000. How much do you have after 1 year? If I'm working this problem, I'm going to find my interest. I would take the principal, the $2,000. I would multiply it by the 4%. Now remember, 4% is a notation. It's not actually a number, so we need to make it a number. We're going to make it 0.04, or 4 out of 100, times, and then it said 1 year. So that's principal times rate times time. And we would learn that we made $80 in that year. So our total amount that we have accumulated, the amount that we have at the end of the year, would be $2,080. But notice how this problem didn't say simple. It said compounded quarterly, and that means that we have to use a different formula. So I'm going to go back to our formula sheet for a minute. Let's just take a look at what it says. This says the amount that we earn, meaning that we're not going to have to add pieces back in, is equal to the principal times 1 plus the rate divided by n raised to the nt power. So what are these extra n's? The n represents the number of compound periods per year. And quarterly would be 4 compound periods per year. So anywhere, if it was quarterly, I'd use 4 here. If it was monthly, I'd use a 12 here. If it was daily, I'd use a 365 here. So understand that n in this situation right here is the number of compounds per year. So let's take a look and go back at this problem again and recognize why this formula is so important. I just did a little bit of work. I just want you to see how I compounded it long using by hand. I used simple interest formula for a quarter year at a time because it was compounded quarterly. So I said, okay, we've got $2,000. We get 4% for a quarter of a year. I earn $20. But then it says you're going to leave that to accumulate. You're going to leave that in the bank. And when we plugged in, now we have our principal is $2,020. And 4% interest a quarter of a year, and this time we didn't earn $20, we earned $20.20. We're going to add that back in, get $2,040.20. We find the interest for that. We get $20.40 for that quarter, and so forth and so on, until we had $2,081.21. Now the difference in those two is not much. We had $2,080 here, we had $2,081.21 there. But what if it was $2 million instead of $2,000? What if it was a bank who had multiple clients, and instead of earning $80, they earned $81.21 every year? That extra $1.21 can add up over time. So compound interest becomes very important, especially in business or anything else that is going to grow exponentially. So what I did instead is I took the formula, remember the compound formula sheet, and I plugged in the numbers, the principal, the rate, the number of compounding periods, and the time. And by plugging all of that in together, I got $2,081.21. That's much simpler than trying to work our way through this long problem. So let's do a few practice problems with that. Let's use our compound formula. Remember that P is the principal. N is the number of compounds per year. The lowercase t right there is time. And the R is the rate they are going to give me. So let's take a look at this first problem. It says I'm going to invest $1,000. That means that's my principal at a rate of 10%. So the rate is 0.10. And they want me to compound it annually, semi-annually, quarterly, monthly, and daily. So they're actually asking me to do 1, 2, 3, 4, 5 problems for 1 year. So we're going to write out up an equation for annually. We're going to write one out for semi-annually. That's twice a year. We're going to write one out for quarterly, one for monthly, and once for daily. Okay? And we're going to have 5 different equations going on. But luckily, we have this simple formula, so it's not too hard to write out. Annually, how much will I accumulate at the end of the year? I'm putting in $1,000. I'm going to do 1 plus the rate, which is 0.10, divided by the number of compounds per year. Well, annually is just 1 compound per year. That's basically looking at a simple interest for 1 year. Now, it would be different if it was multiple years, but we've got 1 compounding, 1 year, so we're just doing basically simple interest. And we find out that we're going to earn $1,100. At the end, that's how much money we will have. We earned $100 in interest. We have $1,100. Now, how does the formula change for semi-annually? Well, the principal was still $1,000. The rate was still 10%, but we're going to compound twice now. And so we change our N value to a 2. When you type that in your calculator, you're going to get $1,102.50. So by compounding it just twice a year, we made an extra $2.50. Quarterly, same formula, same principle, 1 plus the same rate, only quarterly compounds 4 times per year. So we replace both ends with the number 4. That's going to give me $1,103.81. Are you noticing a trend? Look what happens the more we compound. Let's do monthly. A equals 1,000 times 1 plus 0.10 over 12 raised to the 12 times 1. That will give us $1,104.71. And then daily, 1,000 times 1 plus 10% over 365 raised to the 365 times 1 is $1,105.16. So think about a bank. You borrowed money from them. If you just compounded annually, they'd make $100 in interest off of you. But if they compound daily, they make $105.16 off of you. Add that up with all the customers they have, and you can see the reason that most credit cards will either charge you monthly compounding or even daily compounding. So hopefully what you have noticed here is that the more you compound per year, so more compounding means more earned or owed. Okay? More earned or owed. So let's take a look at one more problem here where we have compounding continuously. Remember I said that we had another formula that was compounding continuously. So let's take a look at what that means. A is the amount we're going to have at the end. P is our principal. E is the natural number E. R is the rate, and T is time. So we notice here we've got the amount we're going to have at the end, the principal, that's what we invested, E is the natural number E, R is the rate, and T is the time. So let's look at our problem. It says find the amount, A, that results from a principal, P, of $2,000, annual rate of 8%, and here's the key. This is what you're looking for. Anytime it says continuously, this is the formula we're going to use. And our time is 1 year. So amount I'm going to earn is the principal, which was $2,000, times E, raised to the 0.08, because remember the rate equals a decimal number, not a percent, times 1 year. Well, this is all, there are no variables except for A, so this is a straightforward problem. We're just going to take our calculator and type in 2,000 times E raised to the 0.08 times 1. And the answer that we will come up with is that at the end of the year, we will have $2,166.57. So what if we wanted to work backwards? This time I want you to notice it says, what is the annual rate of interest I need? What is the rate of interest? We're going to compound quarterly, so my N is going to equal 4. We're going to double our investment, and we're going to use 6 years. There's our time. Now, the one thing they don't tell you is the principal. So I want to tell you, I'm a teacher, I'm going to invest some money, and I don't really want to tell you how much I'm going to invest. But I know I want to double what I have now. So let's take the equation A equals P times 1 plus R over N raised to the N times T. And I told you I'm not going to tell you how much money I have now. But what I did tell you is I want to double it. So I want twice what I have now. That's how much I want at the end. Times 1 plus the rate, that's what I'm looking for, compounded quarterly for 6 years. Notice I plugged in everything, and it looks like I still have 2 variables, but notice when I'm simplifying this problem, can't these P's cancel? So I've got P divided by P on both sides, and I just end up with twice as much as I have now times 1 plus R over 4 raised to the 24th power. Now this particular problem is easy to solve using skills that you learned in middle school. How do you solve when you have a 24th power? Well, you take a 24th root. So the 24th root of 2 equals 1 plus R over 4. Working backwards, we will subtract 1. So the 24th root of 2, all minus 1, equals R divided by 4. To isolate the R, I'm going to multiply both sides by 4. So I've got 4 times the 24th root of 2 minus 1 equals R. So the hard part of this problem isn't solving it, it's putting it in the calculator. And you have 2 choices. If I want to enter this into the calculator, I can hit math and choose number 5, because look what happens when I do that. That says a specific root. So I've got the 24th root of 2. Let me put into the number of 2. And then I'm going to subtract 1. Take that answer times 4. And I've got that R equals 0.1172. Banks aren't going to understand the decimal though. They want a percent. So I move my decimal 2 places and I get 11.72% is the rate that I am looking for. I said there were 2 ways to enter it. Remember that the 24th root is also 2 to the 1/24th. So I could enter 2 caret 1/24th minus 1. Notice I got the same answer as I did before, all times 4. Same answer, 0.1172. Now this last problem that we're going to do for finances says how long will it take? They've told me they want to double my value. They told me 6% compounded continuously, so I know what formula I'm going to use. But it says how long to take to double. Remember I told you that if A is equal to PERT, A equals PERT, PE to the RT. I'm not telling you how much I've got, but I want to double it over here. So twice the principal as what I started. I don't know the rate. I know the rate that I'm looking for is 0.06. What I don't know is the time. The P cancels, and I've got 2 equals E to the 0.06 t. I can't solve this problem. I can't take the 0.06 t root. So how do we use that? That's why this is in this chapter. To solve this problem, let's roll it so that we have log base 2. Oh, actually, I'm sorry, it's log base e, because remember, that's the base, that's the exponent. Log base e of 2 is equal to 0.06 t. Now, mathematicians don't write log base e, so I'm going to write natural log of 2 equals 0.06 t. To isolate the t, natural log of 2 divided by 0.06 will give me t. Typing that into my calculator, I've got the natural log of 2 divided by 0.06, and it will take me 11 and a half years. So the time to double my money would be approximately 11 and a half years. Well, what if I wanted to triple it? Instead of double the money here, wouldn't it just be a 3? So for part B, this was question A, part B, how long to triple it, I'm going to write 3 equals e to the 0.06 t. Take the natural log because it's e is the base, so the natural log of the number equals 0.06 t, so that equals the exponent. Divide natural log of natural log of 3 divided by 0.06 equals t. And in this case, the time is approximately 18.3 years. That's all for our financial models. The next video will be unrestricted growth and decay.